Have here is almost very similar, if not almost the exact same question that we had before. Let's investigate these chances, these options one by one. So we want to know which one must be true. So it says by the intermediate value theorem, there's a value c in this interval such that f of c equals 2. Now, in order to apply the intermediate value theorem, like we saw in the last one, we need the function to be continuous. We don't know if f is continuous, so we can't guarantee 1 to be true. By the mean value theorem, there is a value c in the interval such that f prime of c equals 2. And mean value theorem, in order to apply the mean value theorem, we need that f be continuous and differentiable, and we don't know either of those two things. Extreme value theorem, there's a value c in the interval 0 to 3 such that there's a minimum, right? This f of c is less than or equal to all the other values on that interval. But we need, in order to apply the extreme value theorem, we need that f be continuous, which we don't know, and our choice is A. Now, let's go through this if we did know. Let's start off with let f be a continuous function. Okay, it's continuous everywhere, let's say. Okay, now let's see what we can get. Okay, so now let's come up with a hypothetical. So here's our hypothetical. And let's see what we have now. So if f is continuous, right, I want to see if there's a value between 0 and 3. Let's say this is 3 over here, such that f of c, so some c value with f of c equal to 2. So intermediate value theorem, it tells me that by this chart, and I know I'm now assuming that f is continuous, or I'm coming up with this hypothetical. I'm changing this question. So f is continuous. We know for sure f is continuous. So it tells me here that f of 0 is 0. So that's a point. Then it tells me that f of 3 is 6. Let's say that this is 6 up here. Another point. Now, I know that f is continuous. So f is going to go continuously from this point to this point. Now, does that guarantee that there's some value c with f of c equal to 2? Of course, there has to be some c with f of c equal to 2. So that would guarantee 1 being true. Now, would 2 be true? Well, for the mean value theorem to be true, we need something else. We need more than continuous. We need it to be differentiable. So we wouldn't be able to guarantee anything by the mean value theorem. But let's see, the extreme value theorem, would that one be true? Yes, there would have to be some minimum in this interval if we know. And the minimum in this case would just be the 0, 0 value, which is fine. And the max, there would have to be some maximum, which could be the endpoint as well. Or it could look like, it could look like this, right? In which case this would be the maximum. Or it could even look like this, right? Could look like that. I mean, like, technically not, because we know values for 1 and 2, but okay. You guys get the idea. And then the extreme value theorem, yeah, so we would be able to guarantee the extreme value theorem. Yeah, it would have to be some minimum on this. Now let's say we had differentiable. Continuous and differentiable. Now let's see what we could get. Well, we'll definitely be able to guarantee 1 and 3, but now the question is, would we be able to guarantee 2? Okay, so we definitely have 1 and 3 because it's continuous. Now, if I add this differentiability aspect, if it's differentiable and continuous everywhere, right? Now let's see if the mean value theorem guarantees that there's some f prime of c equal to 2. So here I have a little bit of a graph of what f could be. The secant line between these 2 points looks like this. And the mean value theorem basically says that there must exist some c, so this is now no longer my c, there must exist some c, like I think it's going to be maybe right here, where the tangent line, the slope of the tangent line, is the same as the slope of that secant line. So this is C right here. So this would be C. And the slope of this tangent line, you guys should see, is the slope of that secant line. And f prime of C is equal to the slope of that secant line, which is, what's the slope of the secant line in general? So in general, it would be f of b y2 f of minus f of a over b minus a. But in the particular case we have right here, we have it that f of b is 0. That's 0, f of b, I apologize, is 6. That's this point right here, which is 3 comma 6. That's this, 3 comma 6. This is b, this is f of b. And then this is going to be a, and then this is f of a. So it's going to be 0 minus 6, 6 minus 0, because f of a is 0, over b minus a. B is 3, a is 0, so then this is 2. And it is true, look, because you see, f prime of c, there's going to be some tangent line that has the same slope as the secant line on this curve between 0 and 3. So there's going to be some c with f prime of c equal to the slope of that secant line, this secant line. The slope of the secant line in this case is 2. So this equation must be true then, and then all 3 would be true. But since we're not given continuous and differentiable, we know that none of these can be applied, so the answer would be A, none.